Welcome back to 3 Inquisitive Kids. Here is another complicated algebra problem. Now pause the video to try to see if you could solve this on your own. Did you end up solving it? Well, let's find out. Also, if in the end you find out that your solution was different from the one that we showed in this video, definitely put it in the comments down below. We are so excited to see what you have to say about this problem. Now here's the problem. It is given that the inverse proportional function y is equal to k over x, k not being 0, and now here is where I have to clarify that k is a constant, and x is the independent variable here. K over x in quadrant 1 intersects with the linear function y is equal to negative x plus b as shown. Therefore, the graph of function, so here's yet another function, y is equal to x squared minus bx plus k minus 1 could be. And we're being asked to pick one out of these 4 choices. The first thing we have to do is really observe the graphs. So let's first start by observing this graph right here. We see a linear function and we see an inverse function. Now this is very interesting because they intersect at these 2 points right over here. So this one has a y-coordinate of 1, and this one has a x-coordinate of 1. Let's start by looking at this point. Could we find out more about this point? Well, we see that this is a point that's obviously on both graphs. But if we just substitute x is equal to 1 into the inverse function right here, we'll see that this gives us y is equal to k. Therefore, we know that the y-coordinate of this point would be k. Those are the coordinates of this point. And now, if we look into this point, well, we can't really tell anything much about it because we don't even know b. So it would really make no sense to substitute 1 as the y value here. So we can't really find out anything about this point. Now, let's take a closer look at the linear functions, like at each of these functions. Well, we can know the most out of this linear function right here. We know that the standard equation for a linear function is y is equal to mx plus b, where b, the constant, is usually the y-intercept. Here we also have a y-intercept b. So let's plot the y-intercept of this graph. Well, that's right here. That's b. So let me just put it right there. So b, we know, is greater than k. It is above k right here. Is greater than k, and they're both greater than 1. So we can start by, making observations and forming some basic relationships that we see. This is actually super crucial when solving this problem. Now that we have made lots of observations off of this first graph, let's go ahead and observe the choices. So here we have A, B, C, D, 4 choices. And the parts that we have to pay attention to are their differences, because that's the only way we're going to eliminate them, by looking at their differences. So we see that A has a y-intercept that is greater than 1. Right here, see? That is greater than 1. And it has 2 roots on the x-axis. B right here has no y-intercepts except for its vertex, which seems to be sitting straight on that y-axis, and does not intersect with any of these points on the axis. Now let's look at C. C is going through the origin, and so that tells us that 0 is one of its roots. And D here also it has a y-intercept above 1 just like A. Let's take a look at this function. Let me rewrite it down here. The function is y is equal to x squared minus bx plus k minus 1. So this is a standard quadratic function right here. Now let's take a look at what each of these terms represent. Well, we know that these last 2 terms, k being, remember I already reminded you, k is a constant. So k minus 1 has to also be a constant. And this constant determines the y-intercept of the graph. We know that k is greater than 1. which means that there has to be some sort of a y-intercept here. X could be 1.1, x could be 2, but it will definitely have a y-intercept. This is not equal to 0. So there definitely is a y-intercept, and the y-intercept does not equal to 0. Now let's take a look at which ones we could eliminate based on this observation right here. Well, it must have a y-intercept, meaning that B is eliminated. And C does intersect, the y-axis, but it is equal to 0 right at the origin point. And remember, it can't be 0. So C will also have to be eliminated. At this point, we have two different possible answers, A and D. Now let's again compare these two, compare these two choices and see where they are different. Well, they both have a y-intercept that is greater than 1, right? Because the other two have already been eliminated because of that reason. But their difference is that their roots, at least one of their roots, one of them is less than 1, and the other root is greater than 1. So this is the key difference here. How can we find the roots to this function? Now we can apply the quadratic formula. The quadratic formula states that x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And that is in the case of a function that looks like ax squared plus bx plus c. Now let's plug in what we have here into the quadratic formula. Why are we doing this into the quadratic formula? Because we want to find the roots of this function. As you can see, the two different roots here, the only one that is different is the smaller one, because the smaller one is either less than 1 or greater than 1. So in order to find the roots, we're going to try to find the roots and then see if it is indeed less than 1 or greater than 1. So let's plug what we have here into the formula. We would have b plus or minus b squared minus 4 times 1 times k minus 1. We have to look at k minus 1 as a whole here, divided by 2. Now let's first see if option D is right. So if option D, and this is indeed greater than 1, let's see if this is true in the end. Well, all we have to do is solve. We multiply 2 on both sides. To get this. And here we still have a plus or minus. But we know that we are looking at the smaller root, right? We're looking at the smaller root. Therefore, here we could just take the minus sign. We know that if we minus it, we will be getting the smaller root. Now we can subtract 2 on both sides while adding the square root on both sides, giving us b minus 2 is greater than the square root of b squared minus 4k plus 4. Now we take the square of both sides. This gives us this. And then we can just multiply this side out into b squared minus 4b plus 4. Now let's see if this is true. Well, we see that these two sides are the exact same, right? We can cross them out, except for the middle term, which is negative 4b and negative 4k. Is it true that negative 4b is greater than negative 4k? If we add 4k onto the left side, and we add 4b onto the right side, we end up with this. 4k is greater than 4b. Divide 4 on both sides, we have k is greater than b. Is this true? Here's how we fact check this. We go to the top. Here we already said that b is greater than k. So this is contradictory. It means that this is not true. So the first path that we took was false. This is not greater than 1. So because of this, we can already cancel out d because we know that the root cannot be greater than 1. leaving us with only one choice left, A. But let's still, go through the process to see if this is true. We'll do the same thing, except this time we'll say b plus or minus b squared minus 4k plus 4 is less than 2. We're basically copying the second step right here. And from this, we can continue, right? b minus 2 squared would be, and we're still finding the smaller root here, so we're going to use only the subtraction sign, is less than b squared minus 4k plus 4. Now we can multiply this out. And let's see if after simplification, this is true. Well, let's subtract this on both sides, and we have negative 4b is less than negative 4k. We can add them to both sides. So we have k is less than b. Is this true? Well, yes, k is indeed less than b. So this is our final answer, and that is correct. Okay, but maybe not our final answer, right? This only means that this is true, that number A is true. So in the end, our answer would be option A. Thank you so much for watching this video, and we'll see you next time.